Hello viewers, today we will be solving the IB Math A HL November 2024 paper 2 question number 8. You will be getting the solutions for the first 7 questions of this paper and other solved questions from the other past papers in form of playlists on my channel NS Online Math Tutoring classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I'm an online IB Math EHL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start solving this question. The maximum mark is 6. So part A is saying given that W is a complex number, prove that W times W star, that means W times the complex conjugate of W is equal to modulus W whole square. Okay. So W is a complex number, therefore let W be equal to A plus BI. Okay. So its conjugate will be minus BI. Okay. So therefore W times W star is equal to A plus BI times A minus BI, which is equal to A square plus B square. Okay, if you are confused, let me do the multiplication, complete multiplication. I was actually using the identity A plus B times A minus B. So A square, A times A is A square and then minus ABI plus ABI and minus B square I square. Okay, and I square is negative 1 and negative times negative 1 will be positive 1. And these two will be getting cancelled. So this is A square plus B square. Okay, and what is modulus of W? Modulus of W is the square root of A square plus B square. Okay, so this can be written as square root of A square plus B square whole square. Okay, square root of A square plus B square can be written as A square plus B square raised to the power of half. And this whole thing is getting raised to the power of 2. So the half and 2 will be cancelling and we will be getting A square plus B square. Okay, so this is equal to modulus of W square. Okay, so proved. And now two complex numbers Z and W satisfy the following equations. 5 times W star equal to 1 minus 2i times Z square and Z times W equal to 10 plus 10i. Subpart B is saying given that modulus of W is 2 root 5, find Z expressing your answer in the form of A plus BI. That means we have to give Z in Cartesian form where A and B are integers. Okay, so over here also A and B are integers. So part B. Okay, so we are having two complex numbers and we are having two equations. So we should be able to solve. And this is the value given. So that means modulus of W, which is equal to square root of A square plus B square. This is equal to 2 root 5. So therefore A square plus B square, I am squaring both the sides, will be equal to 4 times 5, which is equal to 20. Okay, fine. And I need the value of Z. So let me take this equation first of all, because over here this is Z square and this equation is having the two complex numbers on both the sides. You are having a complex number, but over here both the complex numbers are on one side, but I am choosing this equation because this is containing Z and this is containing Z square. So let's see what happens if I take the second equation first. ZW equal to 10 plus 10i. Okay, and I need z, so this can be written as z equal to 10 plus 10I over W is equal to 10 plus 10I, and W was equal to A plus BI. Okay. And how do we divide complex numbers? We have to multiply with its conjugate, right? Conjugate of the denominator. So 10 plus 10I over A plus BI times A minus BI over A minus BI. Okay. And we have seen A plus BI times A minus BI is equal to A square plus B square. So this is equal to 10 plus 10I times A minus BI over A square plus B square. And A square plus B square equal to 20. So therefore, Z is equal to 10 plus 10I over 20 and A minus BI. A minus BI is W star. Okay, A minus BI is W star. So now we will be using this first equation. So A minus BI, let me write A minus BI and keeping this equation like this, and this is maybe numbered as equation number 1, and we have 5 W star is equal to 1 minus 2I times Z square. Okay, so therefore W star, which is A minus BI, is equal to 1 minus 2I divided by 5 times Z square. Okay, so I will be, this is maybe equation number 2. So I'll be substituting this expression for A minus BI in this equation 1. Okay. So therefore Z is equal to, you can write substituting the expression for A minus BI in 1, we have Z equal to 10 plus 10I over 20 times 1 minus 2I over 5 times Z square. Okay. And now I am dividing both sides by Z. So implies 1 equal to, so I can divide this one by this one and this one by 10. So it is 1 plus I over 2 times 1 minus 2I over 5 times Z. Okay. So this is 1 equal to 1 plus I times 1 minus 2I over 10 Z equal to 1 equal to, I am just expanding this, 1 minus 2I plus I and plus 2, because I times I is minus 1 and there is this minus sign, so minus times minus is plus, and plus 2 over 10 z. Okay. So this is 1 equal to 1 plus 2 is 3, 3 minus I over 10 z. Therefore, z is equal to 10 over 3 minus I, and again I have to multiply with the complex conjugate of 3 minus I, so it is 3 plus I over 3 plus I. So z is equal to 10 times 3 plus I over, this is 3 minus I and this is 3 plus I, a minus bi and a plus bi, where a is 3 and b is 1. It was equal to a squared plus b squared. So a squared is 9 and b squared is 1 square. So let me write it this way. So this is 10 times 3 plus I over 10. Okay. So therefore, z is equal to 3 plus I. So we have completed solving this question. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please do not forget to subscribe to my YouTube channel. Your liking, sharing and subscribing will be really helping me a lot. We meet again very soon in our next session. We'll be solving question number 9 of the same paper. Till then, bye.